All right, I'm going to continue these notes in Chapter 5, Section 2. All right, so in the previous lesson, we talked about how to convert between log and exponential equations. So the bases are going to stay the same. So the base in a log is the little number. The base in an exponent is the big number. The exponent is the little number in an exponent, and the exponent's what it equals in a log, and then whatever it equals in an exponent goes on the inside of a log. All right, kind of just said a lot, but essentially, let's say I give you like 2 to the third equals 8. All right, to convert it to a log, your base is 2, so this would be a log base 2 of whatever it equals, so 8 equals your exponent. And then you would do the same thing vice versa, right? You can always check out that video that I published, right? It was a short video, but we're going to use that same idea when we evaluate functions. All right, so here are a couple of properties of logs. So these are things that are always going to be true no matter what, right? So if I have log with any base, right, any base a, and there's a 1 on the inside, it's always going to equal 0, just because a to the power of 0 is 1, right? You can always convert it to exponential, and then you get a to the 0 is 1, right, which is always true, all right? Similarly, if I have log base a of a, right, as long as this and this are the same, then it's always going to equal 1, just because, again, if you convert and I say a to the first is a, we know that that's always true, all right? The third property is we can extend that and go with any exponent, right? So let's say I have a base a to the power of x. That's, of course, going to equal a to the x, whatever that is on the inside. Similarly, if I take this expression and I turn it into a log equation, right? So this is our base, so it's log base a of x equals your exponent of log base a of x, right? The log base a's are going to cancel out simply, but this is why they would cancel out, right? Because if you convert it to a log equation, then you get an equivalent statement, all right? And then number 4 is the same kind of one-to-one property that you guys had in exponents, right? So let's say I had a to the x equals a to the y, right? On your most recent quiz, you knew that you could just cancel out and then set the exponents equal to each other. All right, same exact thing with logs, right? If the bases are the same, then you can cross out your logs and then you set the x and the y equal to each other. All right, so we're going to see how this is useful when we actually solve for x, all right, and we start plugging numbers in. All right, so let's look at number 7. All right, number 7 says log base 2 of 32 equals x. All right, it's kind of difficult at first to think logarithmically, so what we would do first is convert it to an exponent. I'm going to take that 2, raise it to the power of x, and set it equal to 32. All right, and then you would just use one-to-one property of exponents to get the bases to match. All right, so I get 2 to the power of x equals 2 to the power of 5, right? And then you would cross these out, and then we get x equals 5, all right? Simple as that, right? And then we would try the exact same thing with the next one, right? It's a log equation, but it's easier to think in terms of exponents, so I'm going to go ahead and change this to an exponential equation. So it's going to be 4 to the power of x equals 2. This 2 we can say has an exponent of 1, and then 4 is the same as 2 squared, so this is 2 to the power of 2 to the x equals 2 to the first, and then power to a power you can multiply. So this is 2 to the 2x equals 2 to the first, and then these two cancel out, so we get 2 to the x equals 1. Divide both sides by 2, and we get x equals 1/2. All right, so you guys hopefully see, once you convert it to an exponential equation, it's exactly the same as the previous lesson. All right, so let's try the same thing with this one. All right, again, convert it. I have 3 to the power of x equals 1. And it might seem kind of tricky at first, but anything to the power of 0 is going to get you 1. So this is the same as 3 to the x equals 3 to the 0. And then you would just cross these out, and then we get x equals 0. All right? And this is one way to do it, right? It should be super easy. Another thing that you could do is you could use one of the properties that we learned about on the previous page, that we have log base a of 1 equals 0, right? It doesn't matter what the base is, it's always going to equal 0. All right, so then I have for that x, that's going to equal 0. All right, let's try the same things with the next one. All right, so same exact thing. I have a log base 10, and I'm going to raise that to the power of x and then set it equal to 1 over 100. All right, so I have 10 to the x equals 1 over 100. And then I'm going to do what I did again in the previous lesson, and I'm going to make this into 1 over 10 squared. But I can always change that exponent, make it a negative, and then move it to the top. So this is going to be 10 to the x equals 10 to the negative 2. The 10s cancel out, and so we get x equals negative 2. All right? Same thing with number 11. All right? Again, you could convert it to an exponential equation, just like I did in, what was that, number 9. Or another thing that you can do is we know that this is a property, right? Anything with the 1 on the inside is going to get you 0. So I know already from the jump that 0 equals x. All right. Again, if you're not super comfortable with that, you can always convert it and then say 6 to the power of x equals 1, and then you know that 6 to the power of 0 equals 1, so then x has to equal 0, right? It doesn't really matter how you do it, but I think it's much simpler to remember the properties. All right, let's try the same thing over here, right? I have a base of 5, raise it to the power of x, so I have 5 to the x equals 1 over 125. And then just like before, I can say that this is 1 over 5 to the power of 3. And then this is the same as a negative 3 if I bring it to the top. So then this is 5 to the x is 5 to the negative 3. So then we get x is negative 3. All right. Should be pretty easy as long as we know how to convert between log and exponential. All right. Let's try the same thing over here. All right, so then, yeah, again, right, I'm going to take that 8, raise it to the power of x. So then I have 8 to the x equals the 4th root of 8, right? Something that we might have forgotten about in the very beginning of the school year is that any radical, any number in the radical is going to become a fractional exponent, right? So for example, if I have the square root of x, that's the same as x to the 1/2. Whoa, hang on. Hang on, sorry. Okay, this is the same as x to the 1/2, right? If I have like the cube root of x, that's the same as x to the 1/3, right? If I have the cube root of x squared, that's the same as x to the 2/3, all right? By that same logic, we know that 8 to the power of x has to equal 8 to the 1/4, all right? 4th in the exponent is the same as the 4th root. And then the 8s are going to cancel, and then so we get x is 1/4. All right? We can try the same idea of converting in number 20. All right, this one looks a little bit different because it's actually not a logarithmic equation, right? It might look like it because you see a log, but this actually is an exponential equation because I have a base right here of 3, and then this whole thing is in the exponent, right? So let's convert it to a logarithmic equation. I'm going to take that 3, it's going to be log base 3 of x equals the exponent, so log base 3 of 8. And then we know that log base 3 of x and log base 3 of 8, we can use the one-to-one property and cancel out the log base 3's. And so I very simply just have x equals 8. All right. Another thing that we could do is by another one of our properties, if I have the same base right here in the exponent as I do the logarithm, then these are going to cancel out and you get x equals 8 right away. All right. I think there's another example in here where that would work. Right, this very next one actually, right? We see that this 2 and this log base 2 both have a base of 2. So then what you can do is you can cross out these log base 2's and the 2's, and then you get x equals whatever's left over, so 9. All right, and then it's simple as that. If you don't like how I did that, then you can, of course, convert it to a logarithm, and then you get log base 2 of x equals log base 2 of 9, and then the log base 2's cancel out, and so you get x is 9, all right? But either way, shouldn't be too bad, right? That's just a shortcut that I showed you guys using a property, right? But if you didn't like that, then you can always convert it to logarithmic, all right? Let's try the same thing over here. All right, this one's a little bit different just because now we're looking for the base. We're not looking for whatever it's equal to. But let's just change this, right? So I know that this is going to be x to the negative 2 equals 25. All right. Again, slightly different, but what I would do is I would just try to make the 25 have an exponent of negative 2, right? Because I want the bases to be the same this time. So then I have x to the negative 2 equals, I know that this is the same as 5 to the positive 2. And then to make it a negative 2, all I have to do is bring it to the bottom. So then I get x to the negative 2 equals 1 over 5 to the negative 2. And because we moved it to the bottom, I know that right now the exponents match. X would have to equal 1/5, right? This whole thing right here. All right. All right, if you're not too comfortable with that, it's fine. We won't really come across too many problems like that. We typically like to find what it's equal to already. All right, but that's just one example of a different kind of case that you'll see, right? Something like 23 is another different case, right? I have 4 to the power of 3 equals x. This one should be super easy, right? We're going to do 4 times 4 times 4 to get x, and then you get x is 64. All right? That's all you have to do. And now we can try the same thing with this one, right? This one's nothing special about that one, right? I can just raise 4 to the power of x and then set it equal to the cube root of 16. And then once again, radicals are the same as fractional exponents. So this is the same as 4 to the x equals 16 to the power of 1/3. And then 16 and 4, I know share a base of 4. So this is 4 to the x equals 4 to the second to the 1/3. And then power to a power you can multiply. And then we're left with 4 to the x equals 4 to the 2/3. And then 1-to-1 property, I could just cancel these out and I get x is 2/3. All right. So sometimes they get a little bit more challenging than others, right? But it's still the same exact process, right? Convert it to exponential, use 1-to-1 property to get your answer. All right, and then another part of this lesson that you might come across is something called a natural log. This goes hand in hand with e to the power of x, right? You guys learned about e somewhat recently when we did our money problems. There is an inverse of e to the power of x, and it's log base e of x, right? So the inverse of this is log base e of something, right? So those are the opposites. One way that you can write log base e is ln, right? So log base e and ln are the exact same thing, all right? And that's actually where the button on your calculator, you have an ln button, right? It actually means log base e, all right? So when you press that button, that's what it means, all right? But it has the same exact properties of any other log. So for example, ln of 1 is going to equal 0. ln of e is the same as 1, right? Just because e to the first is e. If I have ln of e to the x, that's going to equal x just because they cancel each other out. Similarly, e and ln cancel out, so then you get x equals x. And then, of course, you can do 1-to-1 property. The ln's can cancel out if I have the ln on both sides. And then you get x equals y. Another thing that you might come across is a common log, all right? That just means log base 10, right? So if I don't see a base like log of x, then you assume the base is 10, right? That's another button in your calculator, right? You have a log button in your calculator. When you click it, it's assumed that there's a log base 10, all right? But again, exact same qualities as any other log expression. All right, so let's give some of these a try. We can convert, again, just like we always do, to an exponential. This is the same as log base e of 1 over e, right? When I see an ln, you might at first want to change it to a log base e equals x, right? And then you have e as your base, convert it to exponential. I get e to the x equals 1 over e, all right? And this is the same as e to the first, but you can make it negative and move it to the top. So this becomes e to the x equals e to the negative 1. And then you can cross out your bases, and then we get x equals negative 1. All right? Now with number 30, you can do what we did before in some other examples and change this to log base e of x equals ln of 5, and then you know that the log base e and ln are the same thing. Or you can just keep in mind that e and ln are inverses and they're always going to cancel each other out. So you're only left with 5. So we get x equals 5 over here. All right, it might seem kind of tricky at first, but the more you practice it, the more you get used to it. Right, same exact thing here, right? I see a property of ln e. Again, ln and e are inverses. They cancel each other out. So this is just going to get you 1. So I get x equals 2 times 1, so x equals 2. All right. Let's do the exact same thing over here. All right. Again, you could convert this to exponential, or you can keep in mind ln and e are inverses. They cancel each other out, so you just get x equals 1/3. All right. So now let's try the same thing with this one. All right. Similar story here. ln of 1 is just 0, so this becomes 5 times 0. So then I get x equals 0 as your answer here. All right, now in this one, ln and e are going to cancel out. They become 1. So I get 3 over 4 times 1, which is just 3 over 4. And that would be your answer for that one. All right, same thing over here. E and ln are going to cancel out, so you're just left with 7 equals x. And so your answer for this one is just 7. All right, that's where I'm going to stop for today. I'm going to save the graphing for a different video. But really, it shouldn't be too bad. We're just solving equations, right? Converting it to exponential and using some basic properties to make some of these problems a little bit easier.